Carbon dioxide is a colorless and odorless gas vital to life on Earth. This naturally occurring chemical compound is composed of a carbon atom covalently double bonded to two oxygen atoms. Carbon dioxide exists in the Earth's atmosphere as a trace gas at a concentration of about 0.04% by volume. Natural sources include volcanoes, hot springs and geysers, and it is freed from carbonate rocks by dissolution in water and acids. Since carbon dioxide is soluble in water, it occurs naturally in groundwater, rivers and lakes, in ice caps and glaciers, and in seawater. It is present in deposits of petroleum and natural gas. Atmospheric carbon dioxide is the primary source of carbon in life on Earth, and its concentration in Earth's pre-industrial atmosphere since late in the Precambrian was regulated by photosynthetic organisms and geological phenomena. As part of the carbon cycle, plants, algae, and cyanobacteria use light energy to photosynthesize carbohydrate from carbon dioxide and water, with oxygen produced as a waste product. Carbon dioxide is produced by plants during respiration. Carbon dioxide is a product of respiration of all aerobic organisms. It is returned to water via the gills of fish and to the air via the lungs of air-breathing land animals, including humans. Carbon dioxide is produced during the processes of decay of organic materials and the fermentation of sugars in bread, beer and wine making. It is produced by combustion of wood, carbohydrates and fossil fuels such as coal, peat, petroleum and natural gas. It is a versatile industrial material, used, for example, as an inert gas in welding and fire extinguishers, as a pressurizing gas in air guns and oil recovery, as a chemical feedstock and in liquid form as a solvent in decaffeination of coffee and supercritical drying. It is added to drinking water and carbonated beverages including beer and champagne to add sparkle. The frozen solid form of CO2, known as dry ice, is used as a refrigerant and as an abrasive in dry ice blasting. Carbon dioxide is an important greenhouse gas. Burning of carbon-based fuels since the Industrial Revolution has rapidly increased its concentration in the atmosphere, leading to global warming. It is also a major cause of ocean acidification since it dissolves in water to form carbonic acid. Background: carbon dioxide was the first gas to be described as a discrete substance. In about 1640, the Flemish chemist Jan Baptist van Helmont observed that when he burned charcoal in a closed vessel, the mass of the resulting ash was much less than that of the original charcoal. His interpretation was that the rest of the charcoal had been transmuted into an invisible substance he termed of gas, or wild spirit. The properties of carbon dioxide were studied more thoroughly in the 1750s by the Scottish physician Joseph Black. He found that limestone could be heated or treated with acids to yield a gas he called fixed air. He observed that the fixed air was denser than air and supported neither flame nor animal life. Black also found that when bubbled through lime water, it would precipitate calcium carbonate. He used this phenomenon to illustrate that carbon dioxide is produced by animal respiration and microbial fermentation. In 1772, English chemist Joseph Priestley published a paper entitled Impregnating Water with Fixed Air, in which he described a process of dripping sulfuric acid on chalk in order to produce carbon dioxide, and forcing the gas to dissolve by agitating a bowl of water in contact with the gas. Carbon dioxide was first liquefied in 1823 by Humphrey Davy and Michael Faraday. The earliest description of solid carbon dioxide was given by Adrien Jean-Pierre Thilaurier, who in 1835 opened a pressurized container of liquid carbon dioxide, only to find that the cooling produced by the rapid evaporation of the liquid yielded a snow of solid CO2. Chemical and physical properties. Structure and bonding. The carbon dioxide molecule is linear and centrosymmetric. The two C=O bonds are equivalent and are short, consistent with double bonding. Since it is centrosymmetric, the molecule has no electrical dipole. Consequently, Only two vibrational bands are observed in the IR spectrum, an antisymmetric stretching mode at 2,349 cm-1 and a degenerate pair of bending modes at 667 cm-1. There is also a symmetric stretching mode at 1,388 cm-1 which is only observed in the Raman spectrum. In aqueous solution, carbon dioxide is soluble in water, in which it reversibly forms H2CO3, which is a weak acid since its ionization in water is incomplete. CO2 plus H2O H2CO3. The hydration equilibrium constant of carbonic acid is. Hence, the majority of the carbon dioxide is not converted into carbonic acid, but remains as a CO2 molecules, not affecting the pH. The relative concentrations of CO2, H2CO3, and the deprotonated forms HCO-3 and CO2-3 depend on the pH, as shown in a Buren plot. In neutral or slightly alkaline water, the bicarbonate form predominates, becoming the most prevalent at the pH of seawater. In very alkaline water, the predominant form is carbonate. The oceans, being mildly alkaline with typical pH equals 8.2–8.5, contain about 120 mg of bicarbonate per liter. Being diprotic, carbonic acid has two acid dissociation constants, the first one for the dissociation into the bicarbonate ion, H2CO3 HCO3- plus H plus Car1 equals 699925000000000000000000000 2.5 times 10⁻⁴ moles, L, pKa1 equals 3.6 at 25 degrees Celsius. This is the true first acid dissociation constant, defined as where the denominator includes only covalently bound H2CO3 and does not include hydrated CO2. The much smaller and often quoted value near 69934160000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 full dissolved CO2 is present as carbonic acid, so that since most of the dissolved CO2 remains as a CO2 molecules, Car1 has a much larger denominator and a much smaller value than the true Car1. The bicarbonate ion is an amphoteric species that can act as an acid or as a base, depending on pH of the solution. At high pH, it dissociates significantly into the carbonate ion, HCO3-CO32- plus H plus Car2 equals 69924690000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 pKa2 equals 10.329. In organisms, carbonic acid production is catalyzed by the enzyme carbonic anhydrase. Chemical reactions of CO2 is a weak electrophile. Its reaction with basic water illustrates this property, in which case hydroxide is the nucleophile. Other nucleophiles react as well. For example, carbanions is provided by Grignard reagents, and organolithium compounds react with CO2 to give carboxylates. Mr plus CO2 are CO2M, where M equals Li or MgBr and R equals alkyl or aryl. In metal carbon dioxide complexes, CO2 serves as a ligand, which can facilitate the conversion of CO2 to other chemicals. The reduction of CO2 to CO is ordinarily a difficult and slow reaction. CO2 plus 2E minus plus 2H plus CO plus H2O. The redox potential for this reaction near pH 7 is about minus 0.53 V versus the standard hydrogen electrode. The nickel-containing enzyme carbon monoxide dehydrogenase catalyzes this process. Physical properties: carbon dioxide is colorless. At low concentrations, the gas is odorless. At higher concentrations it has a sharp, acidic odor. At standard temperature and pressure, the density of carbon dioxide is around 1.98 kilograms per cubic meter, about 1.67 times that of air. Carbon dioxide has no liquid state at pressures below 5.1 standard atmospheres. At 1 atmosphere, the gas deposits directly to a solid at temperatures below -78.5 degrees Celsius, and the solid sublimes directly to a gas above -78.5 degrees Celsius. In its solid state, carbon dioxide is commonly called dry ice. Liquid carbon dioxide forms only at pressures above 5.1 atmospheres. The triple point of carbon dioxide is about 518 kilopascals at -56.6 degrees Celsius. The critical point is 7.38 megapascals at 31.1 degrees Celsius. Another form of solid carbon dioxide observed at high pressure is an amorphous glass-like solid. This form of glass, called carbonire, is produced by supercooling heated CO2 at extreme pressure in a diamond anvil. This discovery confirmed the theory that carbon dioxide could exist in a glass state similar to other members of its elemental family, like silicon and germanium dioxide. Unlike silica and germania glasses, however, carbonire glass is not stable at normal pressures and reverts to gas when pressure is released. At temperatures and pressures above the critical point, carbon dioxide behaves as a supercritical fluid known as supercritical carbon dioxide. Isolation and production. Carbon dioxide can be obtained by distillation from air, but the method is inefficient. Industrially, carbon dioxide is predominantly an unrecovered waste product, produced by several methods which may be practiced at various scales. The combustion of all carbon-based fuels, such as methane, petroleum distillates, coal, wood and generic organic matter produces carbon dioxide and, except in the case of pure carbon, water. As an example, the chemical reaction between methane and oxygen is given below. CH4 plus 2O2 CO2 plus 2H2O. It is produced by thermal decomposition of limestone, CaCO3, by heating at about 850 degrees Celsius. In the manufacture of quicklime, a compound that has many industrial uses, CaCO3 Cal plus CO2 ion is reduced from its oxides with coke in a blast furnace, producing pig iron and carbon dioxide. Carbon dioxide is a byproduct of the industrial production of hydrogen by steam reforming and ammonia synthesis. These processes begin with the reaction of water and natural gas. Acids liberate CO2 from most metal carbonates. Consequently, it may be obtained directly from natural carbon dioxide springs, where it is produced by the action of acidified water on limestone or dolomite. The reaction between hydrochloric acid and calcium carbonate is shown below. CaCO3 plus 2 hydrogen chloride CaCl2 plus H2CO3. The carbonic acid then decomposes to water and CO2. H2CO3 CO2 plus H2O. Such reactions are accompanied by foaming or bubbling, or both, as the gas is released. They have widespread uses in industry because they can be used to neutralize waste acid streams. Carbon dioxide is a byproduct of the fermentation of sugar in the brewing of beer, whiskey and other alcoholic beverages and in the production of bioethanol. Yeast metabolizes sugar to produce CO2 and ethanol, also known as alcohol, as follows. C6H12O62CO2 plus 2C2H5OH. All aerobic organisms produce CO2 when they oxidize carbohydrates, fatty acids, and proteins. The large number of reactions involved are exceedingly complex and not described easily. Refer to the equation for the respiration of glucose and other monosaccharides is C6H12O6 plus 6O26CO2 plus 6H2O. Photoautotrophs use the energy contained in sunlight to photosynthesize simple sugars from CO2 absorbed from the air and water. NCO2 plus NH2O, N plus NO2. Carbon dioxide comprises about 40 to 45% of the gas that emanates from decomposition in landfills. Most of the remaining 50 to 55% is methane.